Welcome to the Noble Ape podcast, Ape Reality. I'm Tom Barbalet, and today, where it all started, or maybe where it all ends, a little discussion with regards to the simulation. I find doing these podcasts, I pull a number of abstract topics out of the air, but I thought it was important to do a 101 with regards to the Noble Ape Simulation, how the various components come together, and somewhat of a reflection as I am currently going through certain aspects of the Noble Ape documentation online with the view, does it answer certain questions? Are there things that are missing from the documentation? Would a new user be completely confused with regards to this thing called Noble Ape? And sadly, some of the time I'm coming back with the answer yes. There are certainly things that appear to be missing from the simulation site, and I think one of the broadest problems with the site currently is that I've stripped away a lot of the very basic kind of discussion pieces to do with the various components of the simulation, in some regard, historically, through removing unnecessary gumph in terms of simplifying the site for Google's AdSense and a number of other things. Some background to this podcast: whilst I was writing the podcast notes, I also watched the start of Hamburger Hill, and Vietnam War films were particularly important in the creation of Noble Ape. It's one of the things I reflect back in the original manuals. Watching Hamburger Hill, I don't think I've seen it actually since 1997, 96, 97, when I watched it over the summer through the formative period of the development of Noble Ape. I was in the shed at the time, I just moved into the shed. And watching it again this morning, I noted that Philip Glass did the music for Hamburger Hill, which draws me to Gerald de Jong, who's a podcast listener. Hello, Gerald. I also want to send a shout out to Bruce Damer, who is tuning in for the first time to the Noble Ape podcast. He has subscribed. He's been mentioned, obviously, in previous podcasts. And also to Tommy, his voiceover talent, who I believe resides in Japan and is very big in kind of Creative Commons vocalization. It's a wonderful thing indeed. The Noble Ape Simulation went through a number of historical changes, and that's actually relatively pertinent because it's the document that I've been working on most closely on the site currently. If you type in nobleape.com, there will be a little link that says, what is the Noble Ape Simulation? You click on that, you get the Noble Ape related history. The discussion that I'm going to give today with regards to Noble Ape Simulation really is talking about the period from the NYU rewrite, but also really the Stockholm rewrite, which gave the simulation a macro structure that it has today, although there have been various twiddlings, and I'll mention that through the podcast. The Noble Ape Simulation really, in a kind of experimental sense, occurred prior to 2001, but in terms of a long-term development sense, was solidified through the Stockholm rewrite, which gave the structure I'm going to describe in this podcast. At the core of the Noble Ape Simulation, funnily enough, is the simulation core. And the simulation core is something which is completely independent. It can be run in a command line environment. It can be taken out and used in other aspects. The component or modularization of the simulation is a long-term project which has connections with the Moon Monkey's development. But the simulation core contains the very fundamentals which are described in Noble Ape Philosophic, which is available on the Noble Ape documentation page. It contains the land, which also includes time. So the land is really the most fundamental component of the simulation. It's the hard stuff in some regard in terms of the landscape. It also has the biological simulation, the quantum mechanics component of the biological simulation in it as well. And that's about that for the land. The land creation uses a random number planar calculation currently. I reflect that the movement from the island to a land environment, a randomly created land environment, really moved from my own movement in some regard from Australia to the US to the UK. But funnily enough, when I arrived in the UK and got back on an island, I then moved to the randomly created land as opposed to strictly island environment. The interesting thing about the randomly created land is it actually comes from the original Planet Noble Ape development. And the idea, which I still hold as a potential, is to put the faces of a cube with the randomly created land as shown in the contemporary simulation, and then spherize the cube, which is a relatively easy mathematical process. This was the central part of the Planet Noble Ape development in terms of creating the landscape, but I digress. In addition to the land and the simulation core, there is also the beings, which basically covers the noble apes currently, may cover fierce felines in the future, covers all aspects of their creation, movement, genetics, and of course the cognitive simulation, which is a huge component of being in terms of the lines of code. The cognitive simulation, thanks in large part to Apple's contribution of specifically optimized brain simulation for the PowerPC G45 series with Ultivec, and for the Intel series the SSE mathematics, which ideally will also be used in Windows and Linux, because it's all Intel now anyway. There's not a lot to be said about the being code, aside from the fact that most of the user interaction in terms of mouse movement and key control and switching between windows and selecting different apes comes through the being code. So there's a lot of sensitivity, particularly in multi-threaded environments, that the individual beings need to be communicative, whether they're selected or these kind of problems. So it's something to reflect on with regards to the being code and the simulation. The final component, which is relatively new in the simulation, however, relates to code that again was written in the same kind of context of the Planet Noble Ape development, but as a separate component, is the weather simulation. And recently I've had most of my fun with the weather simulation in terms of the fact that it's relatively mathematically intensive, but it has also gotten a degree of critical acclaim. And it's rather curious, having developed the simulation, I guess, for 8 or 9 years at the time when I introduced the weather simulation, that more people have contacted me about the weather than anything else in recent times. It's one of those interesting things, adding new features to the simulation. The genetics in the Noble Apes was also a new feature that got some correspondence. However, the weather, because it covers the landscape and very dramatically obvious for that reason, has got a lot of critical feedback, and particularly because the mathematics I use in the weather simulation is my own mathematical musing based on some pressure equations and some ideas of how weather exists as kind of pockets of pressurized water vapor in terms of the creation of clouds. It's purely pseudoscience, but it's very beautiful mathematics, and it does give a very accurate visual description anyway of the way that clouds move and rain falls and weather moves around. Had a great deal of fun writing it initially in 2000-2001, and a greater degree of fun actually implementing it in the simulation, particularly because it is so processor intensive. Moving out of the simulation core, the next component of the simulation that I had divided and identified was the graphical user interface, or GUI, and this is platform independent. One of the key features with Noble Ape the Noble Ape simulation, is that the graphics and a lot of the interactions are platform independent. Now, this is completely unheard of in contemporary computing. Contemporary computing has graphics processing units which are separate processors, or maybe on the same chip but with linking, but very different from contemporary processors, and the reason for that is polygons. And the polygonal narrative with regards to graphics technology is something that I've moved against, and you hear this in the 2000 NYU talk, which is now beautifully put in the podcast. And I also actually included links to the simulation history because it was such a turning point in the development of the simulation, in particular, that NYU talk. So the graphical user interface does a number of things. It does what I call a kind of high-level assembling drawing of the various components. It also handles the mouse and keyboard interactions as they are passed down from the operating specific components. It has various other features like error handling and high-level stuff that can be removed if you were doing it in a command line environment. In contrast to the GUI, there is also a command line environment version of the simulation that actually now uses a lot of the GUI. There are so many smarts in the GUI, particularly with regards to handling movement and doing various high-level things like file opening and passing information, that even now the command line environment uses a large portion of the GUI code too, which may eliminate the use of the term GUI, but it does accurately describe what it does. In addition to this, in kind of the top layer is the platform-specific code. And this in Noble Ape is very, very small, which is particularly striking when a company like Apple, for example, demonstrates the Noble Ape Simulation as an amazing example of Apple's technology. It's something I've always had a quiet chuckle about, that basically most of the technology in the Noble Ape Simulation is actually under that platform layer. In keeping the platform layer really thin, and this is basically operating system calls that take things like the mouse movements, keystrokes, and also drawing to the screen, which is obviously another large component of the Noble Ape Simulation. These are relatively thin, so in the code, lines of code, which is not really a good example, particularly because there are some very powerful functions, including drawing to the screen. The lines of code platform is relatively small compared to the rest of the simulation, and actually that's the way I like it. Because of the way I develop code, I like to actually be developing in the things that will show benefit in Linux, Windows and Mac, and not just Windows or Linux or Mac, for example. So this is why a majority of the Noble Ape Simulation code is actually platform independent, completely platform independent, and it's really just a matter of slotting that thin layer of platform code on top of everything to get it to run on Mac or Windows or Linux. And that's really important to me. But anyway, I digress. Some recent additions, and when I say recent, in the past 3 years, in the case of the Noble Toolkit, I wanted to experiment with the idea of what genetics persisted through warfare. And I was also relatively curious if one could create an accurate warfare simulation, particularly because there were certain components in Noble Ape that I thought would lend itself to that. And that was the seed idea of Noble Warfare, which in some regard is a separate project to the Noble Ape development, in some regard is a child of the Noble Ape development, in some regard is the Noble Ape development. So there's a very strange kind of symbiotic relationship to all these components. But through developing Noble Warfare, there was a need for the low-level graphics that the simulation had, the file handling that the simulation had, and also the universal variables. I use universal variables through the simulation just to make it easier to code, so I know that I'm dealing with 4 bytes of unsigned integer information throughout and these kind of things. It's very important when you compile on different platforms that you're very clear that you're actually getting apples for apples, in the mathematics in particular. So that's one of the many functionalities that the Noble Toolkit provides. It also does some smart math. And this is the thing that frustrates me about math and computers. Things like square roots, random number generation, which is on the cusp of mathematics, finding turning vectors, so it works out whether you're moving towards or away from something, in vision in particular. There is also the line of sight code, and the line of sight code is probably my most favourite abstract code in the simulation, because I use it both for establishing line of sight, i.e. whether one ape can see another ape, but I also use it for drawing lines in the simulation. So it's a perfect reuse of code. The Bresenham function, probably many computer nerds who are into low-level graphics refer to it as their favourite functions, or certainly many of the computer nerds I've associated with, and I guess it's a kindred thing with regards to Bresenham. But that basically describes the stepping that one needs to take, where you take one step and you basically make a line out of all those one steps in the direction in which the steps take. And that's what I use for the line of sight and also the drawing of lines. I had this long-term goal to actually make more of the simulation with functions that have multiple purposes. I think the cognitive simulation and weather simulation could mould together in some regard and then optimise through vector maths, but these are all long-term projects. The most recent addition to the simulation, and probably the poorest in terms of the podcast recording relating to it, although having listened to it again, not too shabby, maybe it's just my reflective mind and the fact that I made a mistake at the start of the podcast, is ApeScript. And ApeScript is one of these things that has come out of a need more than anything. And having described Simulation Core, if you can remember that far back in this podcast, the Simulation Core can be completely removed and replaced with ApeScript, which is a a medium-term experimental goal in some regard, because I would like to see the power of ApeScript actually tested, and also it gives far better debugging of ApeScript. ApeScript has two main components, a parser and an interpreter. And basically what happens is the parser takes the file which has come through the platform, through the GUI, into the Noble toolkit to have all the white space and other related gumph removed, and then into the parser. And what the parser does is takes the text and makes it into an interpretable machine language, for want of a better term. It's not machine code, it's not assembly, but it's a series of bytes which can then easily be interpreted. And the interpreting component of ApeScript is really important, because here's where everything could possibly go wrong. It is really giving a monkey a machine gun, ApeScript, in some regard, because you have the potential to cause crashes, cause all different kinds of problems through just the sheer multiplicity of solutions that are available when one writes ApeScript. The classic example of this that I love to use is the infinite loop, which is, you start at one point, and then you go back to that 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 point, and it keeps going like that forever. And the write-out that I did for the infinite loop is that every, I think it's 10,000 iterations of ApeScript, it then goes back to the operating system, and then it comes back, and then it goes back to the operating system, and then it comes back. So in relatively long ApeScript code, you will have a slight degradation in performance, but the benefit that you get from this degradation in performance is that it won't crash. You'll have an ability to use the menus, to quit out of the application if it's not giving if it's giving all kinds of problems. And that option comes through writing a component of the interpreter that allows for infinite loop related problems. Division by zero, overstepping memory, all these kind of things are in ApeScript's interpreter. And I'd really like to see ApeScript used in other things as well. It's pretty small, compiles to under 10k on the Mac and Windows, and I'm pretty sure Linux as well. And it has a lot of really cool functionality to it, which I've certainly enjoyed. And the documentation is available in the Noble Ape manuals as it's distributed, not to be confused with the original manuals. But I'm always interested in people that are tinkering with ApeScript, and I think there are about a dozen or so people actively tinkering with it. I'd like to see more people tinkering with it. I've had great fun writing it and debugging it and playing with it and seeing what it can do. And I'd like to see if there are any errors. Now, a while ago I had this idea for an ApeScript contest, and I completely lost track of that as being an idea. But the idea with the ApeScript contest was that people would write ApeScript code for cash prizes. And this is something that I probably need to return to in the mid to near term, I think. Mainly because there is so much stuff going on with Noble Ape currently. Some of it is actually quite secret, some of it is soon to become public, but there is so much stuff going on, plus the additional input of an engineer at Intel, Justin Landon is his name, and all these things are coming together currently, plus I'm also doing relatively medium-term consulting, which is taking too much of my time as well. So all these things are coming together, but my priority currently is the mail out and the podcast, and then secondary stuff is looking at the simulation for the Intel folk, and also getting the Windows file handling bug fixed. And by saying it out loud in this podcast, it will be done. Anyway, if you have comments, feedback, questions, tom@nobleape.com. I'm going to do more of these 101 style podcasts, just to put more information out there for new listeners. Welcome again to Bruce and Tommy, and I look forward to new listeners in the future, listening back to this podcast, hopefully to explain what the simulation's about. Thank you very much for listening to this podcast. Look forward to you tuning into the next podcast.